I hope you can now see my screen. All right. So we were still talking about the domain. Okay, so please mute yourself. All right, so the domain, okay, talk about that. Let me begin this right now. Yeah. So now we said the range is the possible y values. So possible y values. Now, the domain of this, it depends on the value of a. Let me do this. The domain, the range actually. The range depends on the value of a. So if a is greater than 0, and this side if a is less than 0. So what will be the domain if a is greater than 0? The domain will be what? Will be y is greater than or equals to the value of q. Remember the value of q from our previous lesson, we said it is the y value of the turning point. So if the range, for the range, if the graph is a concave up, then the range will be y is greater than or equals to q. But if it's a concave down, okay, this is one way of representing it. You can also represent it in this way. Y is an element of what? Of, notice here, the bracket. No? See, it's a square bracket, and then q, and then n positive infinity. But the negative positive infinity, the bracket is round bracket. So this is how you write the range of a parabola. If a is positive, then you just say y is greater than or equals to q. And what is q? Let me write it again here. What did we say is q? Q, we said this is the y value of turning point. I just wrote TP there. Same thing, this q also is the y value of the turning point. But now, when a is less than 0, it means our y is what? Y is less than or equals to q. This is for a less than 0. The range, you say y is less than or equals to q, or you can represent it like this. Y is an element of what? Of, notice the bracket, it's a round bracket, negative infinity, and q. But the q now is what? Is a square bracket. Who can tell us what the square bracket mean and the round bracket mean? Any idea? Why don't we just put the round brackets or square brackets? Is there anyone with an idea why do we do that? Or we just like to do that? No reason. What do you think, guys? Let me know on the chat. Okay, maybe you forgot. Okay, it's fine. I'll assume you forgot. So you see here, the square bracket. When we put in a square bracket, it means we include the value of q. But if it's a round bracket, it means the value like this one, infinity in this case, this one here, it is excluded. If it's a square bracket, it means the value we're including it. But if it's a round bracket, it means we are excluding it. So they are there for a purpose. Don't undermine them. Cool, cool. I think we covered most of the basics. This is what we need to know, and then now we can start with the exercises. Any question before we do that? Any question before we do that? No question. So it's cool. We're off. Okay, let me take a screenshot of this again so that, okay, I see here. I see someone on the chat. Oh, it said no go. Let's go to the questions. Oh, okay. I see. Okay, let me take a screenshot of this. Yeah. All right. Okay, let's go to the questions. Let me change this. Okay, where are the questions? Okay, let me stop share another screen. The one that has got questions. Okay, the questions. All right. What is happening? I want to share the whole slide. Yeah. Slideshow from current slide. Okay, so let's start with this one. It's a simple one. Okay, so let's start with this one. So we've got these two graphs, C of h of x, and then equals to 2x squared plus 4, and then L of x, which is minus 2x squared minus 4. So for each of these graphs, we need to find x-intercept, the turning point, axis of symmetry, and the domain. All right, so let's do that. Let's start with the h of x, the first one here. So for x-intercept, what do we do? For, let me use a green one, a red one. For x-intercept, y equals to 0. So it means we've got y equals to 2x squared minus 4. Then for x-intercept, we equate y to 0. So we're going to say 2x squared minus 4 equals to 0. We transpose 2x squared 2x squared equals to 4 divided by 2 divided by 2. X squared equals to 2. Then put the square root, square root. So x equals to, immediately when you put the square root, it means x equals to plus minus square root 2. Every time when you introduce a square root, here you're going to put plus minus root 2. So that is the x-intercept, but then you have to represent it as a coordinate. So how do you do that? So it means, remember our y is 0 in this case, so it's going to be minus root 2 and 0. This is our first x-intercept, and then the other one you would say root 2 and 0. So this is how you represent your x-intercept. Okay, I hope this is simple. And then y intercept x equals to 0. So we have y equals to 2x squared minus 4. So where there is x, we're going to put 0. So it means y equals to 2 into 0 squared minus 4. Plus 4. So which one was I doing here? Why did I say minus 4? Oh, okay. I see. I started with L of x. Oh, someone is saying he's lost. Yeah, please tell us where you are lost. Tell us where you are lost so that we can find you. Maybe you can raise a hand and tell us where you don't understand.
So I don't understand when we go back from x is equal to positive minus squared from there.
Where?
X is equal to positive or minus into Q.
Oh, this one. This one.
Yes, yes, sir.
Yes, okay. It's a good question. We're doing this graph again. L of x. Okay. So here, what happens? Every time in math, remember we had, let me do it aside here. We had x squared equals to 2, okay? After this step here.
Yes.
But now, for us to solve the value of x, we have to introduce a square root. So every time when you introduce a square root, your answer should be plus minus. It's how, I don't know how to explain, but then every time when you introduce a square root, you have to say plus minus here. If you are doing math properly. So there has to be plus minus root 2. That's why I wrote plus minus root 2 here.
Okay, sir.
Yeah, so it's plus minus there. Okay. All right, so for the y-intercept, x equals to 0. What did I do here? No, wait a minute. There's a mistake I did here. See here, I didn't put I put the plus, the minus instead of plus. Okay, let me start all over again. Okay. All right, so let's start with this one. We said for x-intercept y equals to 0. Okay, so it means y equals to 2x to the power of 2 plus 4. So 0 equals to 2x squared plus 4. Yeah, I made a mistake here. So the 4 is going to go the other way. So it's minus 4 equals to 2x squared divided by 2 divided by 2. Okay, so minus 2 equals to x squared. Okay, square root. But now square root of a negative answer is going to give us undefined. So it means this graph does not have x-intercept. In other words, it does not intersect with the x-axis. This one does not intersect with the x-axis. It only has the y-intercept. So let's do the other graph. Let me do this. Let me erase this. Let's do this one. Y equals to minus 2x squared minus 4. So for x-intercept, except y equals to 0. So minus 2x squared minus 4 equals to 0. So transpose, let me transpose this one. So it's minus 2 x squared equals to 4, and then divide by minus 2, divide by minus 2, x equals to minus 2, square root, plus minus there. Still, this one also gives us undefined. So it means these two graphs, they don't intersect with the x-axis. So they only have the y-intercept. So for y-intercept, x equals to 0. So it means y equals to minus 2, x squared minus 4, which is minus 2 into 0, minus 4. So it means the answer is minus 4. So how do we write it as a coordinate? It's going to be 0 and minus 4. So these are the x and y of that graph. So it's possible sometimes you can get a graph that does not have the x and y intercept. So how does it look like? A graph that doesn't have x and y intercept. Something like this. Let me draw it here. If you have a graph like this, let's say this is my graph, then your graph goes like this. Can you see that this graph, it does have the y-intercept, but then the x-intercept it doesn't have. Why? Because it's not intersecting with the y-axis. It's possible to have a graph like this, or you can have one like this, or you can have one like this one. So you see the x-intercept of this graph are undefined because the graph is not intersecting with the other one. So it's possible to have this kind of graph. So now let's move on to the next thing before we do a more complex one. This is just, or what do you think? Should we go to the past question paper or we just continue with this one before I can do that? What do you think? Let me know on the chat. I've got one from the previous question paper here. Should we do that one or we should just continue with these simple ones? What do you think?
Question paper, sir.
Someone saying I'm inaudible. Maybe it's the network. Okay, so I was asking, should we continue with these ones or we should get a more complex one? Or one?
Get the more complex ones,
Okay.
please.
Okay. All right. Let me share the screen of that one. Let me first take a screenshot of this. One from the previous question paper here that we can do. Okay. So let me close this one. So that what's wrong here? Yeah. Let me stop this one and share another one. Share this one. Oops, not this one. Yeah, let's start with this one. Okay. So here is the question. Okay, all right. So the graphs f of x equals to ax squared plus bx plus c They said a is not equals to 0, and we've got that of g of x, which is mx plus k. They are drawn below. You can see the questions that are drawn there. I think you can all see. D, we've got coordinate D. Let me highlight it. Here is coordinate D. We are given coordinate D, it's 1 and minus 8. And at coordinate D, it's a common point. So it means at coordinate D, the graph of F and the graph of G are the same. Okay, someone in the background forgot to mute their mics. Okay, I just muted them. All right. So they said this coordinate is a common point. This is where the graph of G and the graph of F meet. Okay. And then we've got the x-intercept. Do you see we've got this one and that one? -3 and 0 and 2 and 0. This is our x-intercept. All right. Then we've got G is a tangent to F at D. It's a tangent. Tangent is a line that touches the graph once. So it means G is a tangent. You can see that. Now, they're asking you for which values of x is f of x greater than or equal to 0. Now, this question, if they ask you for which values of f of x less than or equals to 0, what they mean, what do you understand by the less than or equals to 0? It means they're asking for the values of x where this graph of f is below or is negative. Can you see from here going down, the graph is what? It's negative. But from the same point going up, the graph is positive. So if they ask you for which values of x, f of x is less than 0, what they're asking you is where the graph of x is below this line. Want the values of x where the graph is below this line. You can see the line I've drawn going down. So all the values of x from here. So what are those values? You can see it's from here. Let me use a different color. It's from this point up to this point. The graph is less than 0, or it's negative, or it's below this x-axis. So if you get a statement like this, it means below x. It means below x-axis. So f of x less than 0, it means below x-axis. So it's below x-axis at this point. So we need to tell the values of x. So it's simple, we just look from the graph. The values of x from this point to this point is what? We can see that x, you can see, so it's between 2 and -3. So when x is between 2 and -3, and -3 and 2, the graph is negative. That means if we had an equation of f, if we substitute any value of x that is between these 2 points, we're going to get a negative answer. That's what it means. Okay, we'll deal with that as time goes. Now, determine the values of a, b, c. In other words, determine the equation of the graph. So we have enough information for us to determine the equation of the graph, and it's 5 marks. So we can just collect all the 5 marks and we go out of the exam room smile. So let's do that. Remember, I told you about the the 3 standard forms of the graph. We said we had y equals to ax squared plus bx plus c. We had y equals to a into x minus x1 into x minus x2. We also had y equals to a into x minus p squared plus q. So we need to know which one we're going to use between these ones. But looking at this, we have the x-intercept. Do you see? -3 and 0, 2 and 0. So we're going to opt for this one. Our life will be easy if we use this method, this one. Our life will become easy if we use this one because we've got the x-intercept. So let's do that. Y equals to a into x minus x1, x minus x2. All right, so let's substitute y equals to a because we don't know the value of a, and then x. We said this x1 is what? It is the first value of the x-intercept. It's either you substitute this value or this one. So either way. So let's substitute -3. So it's going to be minus. This minus is for the formula. You see here it's minus. So I said minus. Then the value that I'm substituting is also -3. So it's going to be what? Open bracket, -3. Then close, then x. So I substituted this one. Now I have to substitute the second one. Remember, it's 2 here. So it's going to be x minus 2. So it will be what? It will be y equals to a into x. X minus -3, it's going to be x plus 3 into x plus 2. Any questions so far before I proceed? If you're fine, just give me a thumbs up as we are moving. Just give me a thumbs up if you understand before I continue. Or if you don't understand, raise your hand. Okay, it's fine. So I assume that you all understand.
Sir,
Yes.
on the last step, you said that x plus 3 open bracket x plus 2. Isn't it supposed to be a minus since you put a
Yes.
minus at the step?
Yes, that's correct. It's minus. I made a mistake. Thank you for that. Yeah, it's -2. Yes, it's correct. It's a -2. Then, for us, we need to find the value of a. And once we get the value of a, now we can have our equation. So how are we going to get? Okay. Is there anyone
Yes.
want to ask a question? Okay, no one. Let's mute yourself. Please mute yourself so that we don't get to. Okay, fine. Okay, fine. So now let's get the value of a. To get the value of a, we can substitute any point on the graph. So the point that we're substituting, we have to make sure that it lies on that particular graph. All right. So it's going to be what? Let's substitute this point D. It's 1 and -8. So y is going to be -8 equals to a into the value of x is 1. So it's 1 plus 3 into 1 minus 2. So we're going to have -8 equals to a into 4 multiplied by 1 minus 2 is -1. So we're going to get what? -4a. -4a equals to -8 divided by -4 divided by -4. So 2 equals to a. So now we have our value of a. So it means y is going to be, a is what? It's 2 into x plus 3 x minus 2. We're not done. We can remove the brackets. I'm running out of space here. Let me do it here. Where? Okay, it's fine. Let me do it here. So y equals to, I want to remove the brackets by multiplying in those ones. So the 2 will be out like this. Then I'll have x squared minus 2x plus 3x minus 6. Then I will have y equals to 2 into x squared minus 2x plus 3x. I'm going to give up plus x minus 6. Then the final equation will be what? Y equals to, I'm factoring in 2 now. So it's going to be 2x squared plus 2x minus 12. So that's my equation. So if the question said determine the values of A, B, C, the value of A is what? It's 2. Let me do this. This is the value of A. The value of B is 2 also. The value of C, 12, minus 12.
It's 12.
Yeah, this is C. Let me just do this. Then we are good. If this is the case, this is C. Then we are fine. Okay. All right. I think you all understand. Okay. Minus 2x. Let me write it down here. So it's 2x squared plus 2x. 2x squared plus 2x minus 12. Right. So that is that. And let me clear this so that we can go to the next question. Let me clear all drawings. Cool. Now, write down the equation of the axis of symmetry of h if h of x is f of x minus 7 plus 2. Oh, someone has a question. Oh, so what? Oh, saying, yeah, I'll send on WhatsApp. Yes, I'll send on WhatsApp. All right, so write down the equation of the axis of symmetry. So how do you find the equation of the axis of symmetry? We're going to say y.
Sir,
Yes.
you skip the question, determine the coordinates of the turning point.
Oh, yes. Okay, let me write the equation again here so that we can determine. It was 2x squared plus 2x minus 12. Yeah. Move this thing down here. Okay, so it's going to be, okay, for the turning point, you simply say x equals to minus b over 2a, which is minus b is what? Minus 2 over 2 into 2. Remember, the value of a is 2, the value of b is 2. So the minus is for the formula here. It's minus b. So this is the minus for the formula. So it's going to give us minus 2 over 4, which is minus 1 over 2. Okay? Okay. Yeah. Just mute yourself so that you don't disturb others. Okay. Yeah. So this is the x value, and then y is going to be what? We're going to substitute this x value into that. So it's going to be 2 into minus 1 over 2 squared plus 2 into 1 over 2 minus 12. Then we will have to press the calculator, and it should give us. Okay, so let me try to press the calculator here. You can also do on your side and see how much we get. So it's 2 into minus 1 over 2 squared. Yeah, just mute yourself, please. Mute yourself, please. Over 2 minus 12. Minus 10,5.
Is 21 over 2. Is
Yes.
negative 21 over 2.
Yes. So now it means the turning point will be minus 1 over 2 and minus 21 over 2. Okay. Someone speaking on the background, please. Please mute. Please mute. Okay. So this is the turning point, TP. I hope it's pretty cool and simple. Write down the equation of the axis of symmetry of that graph. So x is
So,
yes.
sorry to disturb. The turning point is -1/2 and -25/2 because you said you didn't put the minus sign there on top where there is 2/1. The first part,
That's easy.
yeah.
Oh yeah.
So the answer is -1/2 and -25/2.
Okay. Thanks for that. Yeah. 25/2. Yes. Thank you for that. Thank you for that. Okay. So pay attention, guys. It's easy to make a mistake on these things. Okay. So it's fine. Let's proceed. Now, the equation of the axis of symmetry, that is f of x minus 7 plus 2. So what do we see here? You see, h of x is the same graph of h of x, né? But now x minus 7, it means it is the same graph that shifted 7 units to the right and 2 units up. Né? So when it comes to shifting, the turning point form is the best one to show, to deal with the shifting and all those things. Today I didn't want to do the shifting. We'll do the shifting tomorrow and together with the gradient of the other one. So we'll do the shifting tomorrow. For now, we just want to focus on getting the equation, drawing the graph, and doing all those things. Then we'll get to the shifting. Even these things of where values of x greater than 0, less than 0, whatever. So we'll deal with that when we are done with this. So for now, focus on finding the equation and the turning point and drawing the graph if you have a situation that requires that. Then the shifting, we'll talk about that on Friday. We will have its own class for that. All right, so that's what we wanted to do today. That's what we wanted to do today until we meet again on Friday. But then I'll send some work for you to do so that we'll see how far you understand. Yeah, so we'll talk about the shifting and the other one of gradient on our next class. Okay, yeah, so that's it for today. We'll talk about the other things later. All right, have a good evening. Until